So, hi everybody. I'm Sam Hogarth. I am the principal engineer for platform engineering at Tesco Bank in the UK. Tesco are a big store, and Tesco Bank is the personal finance arm of that. We're a medium-sized bank. We've been around since about 1997, and we've recently been acquired by Barclays Bank, so we're now part of that global Barclays family. What I want to do today is take some of your time and talk about some real world use cases, putting this in practice. What are the lessons? What are the things that we learned along the way? So for a bit of context, the bank was built in 1997 and was largely running in data centers. Around 2014 to 2018 was when the bank was starting to put its foot in the door in cloud compute. And it's been a bit of a journey since then. We've been getting out of our data centers and moving to a fully cloud operating bank. And we're now at the point in our journey where we are really starting to mature those running practices, how we build for the cloud, how we run, how we operate. And so as part of this, obviously what happens at any point in this journey is you end up with some cost challenges. Getting out of a data center, moving that kind of workload, the big batches, big customer processing systems that run there, that's hard work. And sometimes you need to take decisions which aren't the most cost effective in the here and now, but will help you later on. So that's where we are. We've stood up a FinOps department. We've been operating a FinOps function for just over a year now. So we're at a really good point to checkpoint and talk through what we've learned. The first thing is building any new function, new capability in an organization. It's inherently a political act, and it's about winning hearts and minds. The first thing that we set out to do is create the snowball effect, create momentum around this, make it so that people get excited, people really buy into the idea of what FinOps means for them, how they work, how they engage with their products, and how they can help serve customers a little better every day. That comes with explaining who we are, what we're doing, why are we here? The first thing we had to explain to people is that we are not bean counters and we're not gatekeepers. We're here as a complementary function. So what we don't want to be doing in FinOps is wielding the sign-off pen and saying, yes, your application can proceed, or your application is not cost efficient, or your service is not profitable, anything like that. We don't want to be these arbiters of decisions. What we want to do is we want to help the bank make more effective decisions, make more effective spend choices. So we sit the intersection of engineering and product architecture and finance. We bring these disciplines together and use a common language so that we can talk about how we build and what value means and how we deliver on that, how we can measure it. So over the past couple of days at this event, we've talked a lot about tagging, and I don't want to get too much into the details of what tagging is. It depends on your cloud platform, how you do it. But given that I'm from a bank which belongs to a shop, the easiest metaphor I could find was that it's like a barcode. It's a way of identifying what a particular piece of cloud resource means. Who does it belong to? Why do we have it here? And we can use it to add metadata, like what kind of data classification does this have? Or who do you need to contact if there's a problem? And we can use tagging for a wide variety of purposes. What we use it for in FinOps right now, where I work, is cost allocation. So we know which of our value streams or which of our platform teams are spending money and on what products or offerings. We also use it to perform anomaly detection, so we can look at that cost allocation, and similar to trend analysis, we can start to profile that usage. We can see, is spend going up, is spend going down, and start to ask questions about, was that expected? Is there a change that you have deliberately, consciously made in your application that expected your spend to go up or expected your spend to go down? We're not trying to judge that spend as good or bad. We're trying to make it visible and let people digest that, understand it, and then apply that to the product. So if the cost is going up and it's not expected, we can do something about it. If the cost is going up and we do expect it because a new feature has came in that has increased our market share or something like that, then that's fine. We can record it and we can properly attribute it. The other thing that we can do is we can then identify where our opportunities are for cost saving and cost effectiveness, and we can reach out to the correct teams or product owners and start to have those conversations about what can we do here? How can we make some adjustments to your product or the way it runs or the way it's built, the way it operates to be more cost effective? The way that we've approached this is in layers, following the FinOps model of crawl, walk, run. Okay, we have tagging standards. It took a lot of effort to get tagging to a place where we needed it to be. That involved a lot of manual tagging, going into existing resources, having conversations with engineers, working out what belongs to whom, and essentially reducing the amount of unknown, untagged resources down to a predictable set. Once we could get to that place, we could then start to place automated reporting on top of that tagging effort. So we can start to see, hey, you've got some resources here. We have a tagging standard over here. Are you compliant with that? We can show that back to engineers and make sure that we are maintaining tagging standards, that we aren't slipping. Building that in, getting engineers to engage with that on a monthly basis has been an interesting experience, but we've got there. We're at a really good tagging position now where the vast majority of our workloads are fully compliant with our tagging standard. We have a few stragglers that we're still working through because this stuff is a long tail. Of course, you're going to have that. The next step for us is to then start to apply organizational policies. So in the spirit of making undesired state unrepresentable in your system, what we want to do is we want to place automated guardrails in place so that you cannot provision resources unless you are fully compliant with our tagging standard. And this isn't just important for FinOps, this is important for security too, so that we can make sure that if there's a new vulnerability, new incident, the correct teams are engaged. So we are trying to lift everybody up by these automated guardrails. Having that minimum standard that you need to adhere to gives you the confidence to project data from that and to have data-driven conversations. One of the first things that you'll do when you get started in FinOps is look at the central actions that you can perform. So if you take a look at your compute spend, what you'll see is a fairly large amorphous blob of spend that it's difficult to attribute to why are we spending it and who does it belong to and in what way. And it becomes difficult to draw any patterns or inferences from that. Tagging helps. That's a big part of it. What you can also do is you can look at the patterns through the day and try and see, this is our current spend, but can we identify a sensible baseline that we can start making cost conversations from? So the first thing that you can do is turn the lights off. It's the simple, if you're not using EC2s, you're not using cloud resources, don't pay for them. Don't rent them when you're not needing them. there's a bit of a mindset shift here in that you need people to understand that in the cloud, you're following a rental model. You're paying for things by the hour based on your usage. You're not procuring a physical piece of hardware that is sitting in a data center that you own, that you need to amortize the cost for its life cycle. Okay, if you don't need a resource, you can turn it off. You can get rid of it and put it back on until you need it. So we put in place some really top level scheduling. We are able to automatically shut down our development and test environments when we all go home for the evening, and we keep them off over the weekend. What you then start to see is spikes in your compute usage. So you can see there where you have your optional spend and where you have your mandatory spend. And you can start to draw a baseline of this is kind of how much we are spending. And from there, you can then use the tagging to enrich this data and understand who is responsible for that spend. The other big central lever that you have to pull on your compute spend is once you can visualize that as a block of spend, you can start to engage in bulk discounting. Very convenient for a big UK supermarket, right? In AWS, this is your savings plans. The approach that we've settled on, the metaphor that we use internally for buying savings plans, is the Lego brick approach. So what we don't want to do is draw that horizontal line where our known predictable usage is and buy a single savings plan to cover that for a long period of time. There are a few competing factors here. Savings plans are ultimately a trade-off between several things. You are selling some flexibility because you are committing to a known predictable usage of compute cost for a period of time. That's why Azure calls them commitment discounts, because you're committing that compute spend. So that means if you're going to spend, you need to make sure that you're going to use, because you're still going to be charged even if you don't use that full spend. What you're getting back in return, what you are buying with that money is a cheaper hourly rental rate, essentially. The longer you commit for, the cheaper that discount can be because you're selling your predictability. But there needs to be a balance. The other thing that you need to do is you need to be able to retain some of your optionality, some of your flexibility, some of your agility within your savings plans. So rather than having one single savings plans that say you want to cover 80% of your compute spend, rather than having one single big Lego brick to cover that entire spend, actually what you want to do is compose it of smaller Lego bricks and build a model. Build in different amounts of commitments and they stack. Offset them so that they expire at different periods, which gives you the opportunity to sense check and to adjust if the bank's environment has changed. Let's say we've just landed a big new product that's increased our compute spend. We may want to increase our coverage to accommodate for that. Let's say somebody's just re-architected an entire heavyweight monolithic EC2 system into a bunch of lightweight lambdas. Maybe we don't need that compute spend anymore, and maybe we can adjust our commitment tier down. So by seeing this as Lego bricks, we can basically use the modularity to give us the ability to react to how we are using our spend. And then by engaging engineering, engaging product, we were then able to work with our distributed teams in their value streams, in their platform teams, and get some seismic shifts. And here are some of the big things that we've done over the past year that have put a significant notch into our spend. So compute right sizing, following a data center mentality, people would typically over provision EC2 instances on a just in case basis. We were able to use right sizing recommendations from our vendors to have conversations with engineers and say, it's appropriate for you to scale this down based on your usage patterns. And by doing that, we're not renting as much compute, we're not paying for as much compute. GP2 to GP3 migration for storage was a huge cost-saving effort for us. The great thing about this is there is no service interruption as well. So this was a really great technical change that we could work with engineers who weren't as experienced in FinOps, who were just testing the waters in this new world. We could give them a fairly safe change that would have a big impact, wouldn't require downtime, wouldn't require huge coordination, and then they could take that to the bank. So if you still have GP2 workloads, consider moving to GP3. You will get increased throughput, you will get cheaper storage, and yeah, you don't have to take anything offline to do it. EBS volumes and snapshots clean up. So you tend to accumulate a lot of this stuff over time if you're a large enough organization. Having unattached volumes, so that means they're not currently being consumed by some kind of compute resource, is okay on a temporary basis. But if they're just sitting there for long term, that all they're doing is accumulating spend. So what we did was we helped teams to understand which volumes they needed and which volumes they could clean up. The ones that they wanted to take backups of, we took snapshots of because they are considerably cheaper to keep. But even then, we looked through snapshots and we cleaned stuff up. So we put in place retention policies so that data can expire when we don't need to keep it anymore. And that really minimizes the amount of storage space that we're paying for. S3 lifecycle management. I'm going to go into this one in a bit more detail. We realized some huge cost savings by putting appropriate lifecycle management policies in place for our storage buckets. And then CloudTrail and config management. I'll cover this one as well. At the organization level, at the platform level, we need to collect audit logs from all of our AWS accounts about what activity is going on. It's a huge volume of data. It consumes a huge amount of storage, and it has a very high throughput, which creates some very interesting conditions for cost saving. Let's go into some detail about that. The first thing that we found with S3 is that movement matters as well as how you're storing your data. So in S3, storage is relatively cheap, and it's charged on a per gigabyte basis per month. One of the very common cost-saving exercises that you can do with S3 is move your data into a different lifecycle tier, like Glacier. And the idea is if it's infrequently accessed, you can trade off a little bit of retrieval speed for cheaper storage. And this is great, but you also have to pay to move your data from one tier to another. And the way that you are charged for transfers is not per gigabyte, it's per the number of object requests. So for things like CloudTrail logs, where you have lots of small files, it can actually be, if you do these sums, it can actually be more economical to just keep things in the standard storage bucket. You're paying more per gigabyte for the storage, but that is considerably offset by not having to pay for transferring all of those objects. So like a year's worth of our AWS config data, we were talking, I think it was 600 million objects, and it wasn't actually consuming that much storage, but we were paying more on our S3 bill purely for transitioning all of those objects into Glacier and then into an even more infrequently accessed bucket than it would have been over the life cycle of that data just to keep it in the standard tier. So the lesson there is it's not just the size, it's the quantity as well. We got a 70% saving overall on our storage by applying these sensibly. The other thing we found with S3 is that If you have versioning enabled on your buckets so that you can go back to previous versions of objects, when you perform a delete, you're not actually deleting the object, it's a logical delete. That's by design. It's deliberate. It's so that you can get something back if you accidentally deleted it. What happens is all of those previous versions of the object are still there. You're still paying for them. If you need them, great, that's fine. When you delete an object, what happens is a very, very lightweight bit of storage called a delete marker is consumed and set to be the latest version of that object, so that when you retrieve it, you don't get anything back, and that indicates that the file is deleted. So what we needed to do with our lifecycle policies is also set up some rules to say, what should we do with old versions of objects? And the delete markers, we need to make sure that we clean all of this stuff up as well. How you do that is going to depend on the storage, the data retention policies, all of that kind of stuff. But when we had these conversations and we put them in place with our engineers, we ended up with a 91% saving on this type of storage. Absolutely crazy numbers. We also made some mistakes as well, trying to do the right thing. So we put in place automation to assist engineers to try and lift the bar and make the difficult things easy. So I was talking earlier about our tagging compliance and the automated scans. We put that in place and we ramped up the frequency at which it was recording so that developers could get fast feedback on whether their resources were compliant with the standard. And then what we found was an absolute explosion in cost from AWS config. And being a bank, having strict audit requirements, having strict security requirements, what we actually found here was that introduced a cascading cost effect, where because the Lambdas were running more frequently, they were producing more config events, which was causing more config rules to be evaluated, which you're charged for, which was causing more reports into Security Hub. So it exploded. One of the things we found with a particular, if you were tagging something, if you send a request to AWS to tag a resource with certain values, if the resource already has those tag values, the end result is a no-op, right? Because it already has all the tag values. It's still recorded as a config event. It's empty, but because it's a config event, it's going to be evaluated by all of your security mechanisms, and that's where the cost came from. So what I'm saying here is you also need to be conscious if you're putting in place, if you're wanting to move from the crawl to the walk to the run phase, that the automations that you put in place to support your engineers don't actually compound your cost. Fixing that was a 96% saving on our config rule evaluation. And just to finish up, we're a bank, we belong to a store, and that store has a very popular phrase in the UK, every little helps. And that's an important lesson to take home in a FinOps talk. Every little does help. These small wins can compound and cascade into large scale change. At the level of a bank, that means millions of pounds, millions of dollars, just by virtue of the scale you operate at. I want to give you some kind of take home numbers from us. A year in, we're 20% down on our bill. Our hourly run rate is down 15%. Our efficiency score, measured in terms of how right-sized are our workloads based on how they operate, we're at 87%. And we have had 12 successive months now of month-on-month lower bills, which shows that not only are we taking the big moves, but we are building this into our engineering culture. And we're starting to have our engineers think, what's the financially prudent way to do this? And that's all I have for you today. I hope that little whirlwind tour through what we've been up to for the last year was very useful for you, and enjoy the rest of the event. Thank you.